Okay, good day everybody. Today we are looking at mathematics once more. My name is Afolabi, and today I will be taking on you on inequalities, the basis of inequalities. In our prior videos, we have discussed so many forms of algebraic processes. So today we'll be moving on to inequalities. Don't forget to punch on the subscribe button under this video and to like and comment as you watch the video. Thank you. So inequalities is about values that are not the same on both sides of the expression. Values that are either greater than or less than. The common signs that we use in inequality expressions are less than. This sign here means less than. That means what you have in this part is less than what you have here. For example, your 2 is less than 6. You can see, so what you have on this part is less than what you have on this part. So this is less than, this is greater than, this is less than or equal to. Okay, there are some expressions you don't know, they might be less than or equal to. This is greater than or equal to what you have here. And this is not equal to. So we have about 5 inequality signs that are commonly used. And based on the operation of these inequalities, there are 2 basic operations that are very, very important for mathematics, and that is talking about the inversion of the signs. Okay, if you have 2 numbers and you have A to be greater than B, okay, by the time you multiply the 2 numbers by a negative number, what happens to the sign? The sign will change. Look at it, your minus B will become less than minus, your minus A will become less than minus B. Look at it for instance, let's say you have 2, which is greater than 1. 2 is greater than 1, we all agree to this. This is based on what we have here. 2 is greater than 1. But immediately both of them changes to minus. We have minus 2 and minus 1. Which one will become greater? Then minus 1 will become greater. So whenever you bring in a negative, whenever you have a negative operand in your inequality, the sign will change. Likewise, what we have here, look at when we have A is less than B, for example, when you had 2 to be less than 7, okay, and you now bring in a negative number, what happens? You have minus 2 and minus 7, what happens? Definitely, it will be greater. So the summary to this operation is that anytime we are dealing with a negative value, okay, either you are multiplying or dividing by a negative value in your inequality, what happens? The sign of the inequality will change. Anytime you are dealing with a negative or positive value, the sign will change. For example, if you have if you are told to find the range of x, find the range of x for which 3 minus 2x is less than or equal to minus 7. 3 minus 2x is less than or equal to minus 7. Look at this simple question here. Remember, the same operations that we have for algebraic processes is still used for inequality. That is, we collect like terms, we divide both sides by the coefficients and all that. So the first thing I'll do is to take this 3 to the other side because this is the like term. So I have minus 2x is less than or equal to minus 7 minus 3. You can see the sign of the sign changes from plus 3 to minus 3 when it gets here. So we have minus 2x is less than or equal to minus 10, isn't it? But look at it here. We have minus 2x is less than or equal to minus 10. I'm to divide both sides now by what? By the coefficient of x, which is minus 2. So our minus 2x over minus 2 will be what? Minus 10 over minus 2. What happens to the sign? So this operation now comes in. As I'm dividing by a negative number, what happens? This sign will change from less than or equal to the opposite. The opposite of less than or equal to is what? Is greater than or equal to. So minus 2 cancels minus 2. Okay, here I have minus cancelling minus, and 10 to go in 10, and that means my x will be greater than or equal to 5. So this is just a summary to let you know that anytime we are dividing or multiplying both sides of an expression inequality with a negative number, what happens? The sign of the inequality will definitely change. The sign will definitely change anytime I'm dividing by a negative number. But that is not the case when I'm not dividing by a negative number. The only time the sign will change is when I'm dividing by a negative number, just as I have here. If I'm not dividing by a negative number, then the sign does not need to change. Look at what I have here. 4x minus 1 is greater than 2x minus 5. The same thing I'll still do. I'll collect like terms, I'll transfer the 2x to this side. I'll transfer the minus 1 here. So I have 4x minus 2x is what greater than minus 5 plus 1, isn't it? I think that's correct. Okay, so here I have 2x is greater than what? Minus 4. So if I'm going to get x from here, what will I do? I'll divide both sides by 2. The coefficient of what? Of x. But here the coefficient of x is not a negative number. Unlike here, when the coefficient of x was a negative number. When the coefficient of x was a negative number, the sign changed from less than or equal to greater than or equal to. But here we are dealing with a positive number. The sign will still remain the same as greater than. So 2 cancels 2. Okay, and 2 will go here minus 2. So I have x to be greater than minus 2. So definitely this is the range of the value of x for this equation, showing us that what the sign will only change when we are dealing with a negative number. Okay, so the next thing is how to represent these inequalities in number line. You know, inequality is not really telling you that the answer for a particular unknown is a value. No, the thing inequality is telling you is that, okay, the range of values that obey the given expression you are given is on that expression. So you can have expressions such as okay, let's say we are represent the following on number line. Represent the following on number line. We have x is greater than minus 5. We have x is less than or equal to 0, and we have x is greater than or equal to 2. I want to represent these three numbers on number line. Remember the steps taken. The first thing is that I will draw the number line. I will indicate the 0 and the number. So let me do the first one. I will indicate the number line. This is the number line, the x, and I will indicate the 0. Okay. This is the x-axis, the number line. So I will indicate the 0. Then I will indicate the given mark, the number that is given. The number given here is what? Minus 5. Where will minus 5 be? On this side. This is minus 5. It should not be on this side. This side is for positive, while this side is for negative, and this is 0 mark. Just like your x and y axis. This is the x-axis and y-axis. Yes for positive, yes for negative. So I'm only taking the x-axis down here. So the next thing after that is that I will erect a null at the given number. What's the given number? 5. I will erect a null there. Okay, I've erected a null there. Then I'll do what? I will indicate the direction of the arrowhead using the inequality. That statement is kind of ambiguous, but it's very simple. Look at the inequality I have here. The inequality I have is x is greater than minus 5. Look at the greater than minus 5. So which of the arrowheads we have this as the head? We have two types of arrowhead. We have this or we have this. So which of them has this as the arrowhead? Definitely is the first arrowhead here. So definitely I'm going to have this connected to the null. So this is connected to the null. So what I have here is a representation of all the values that are what? That are greater than minus 5. Very simple. The first thing is you draw the number line, you indicate the null, you indicate the given number, put a null on the given number, then show what? The direction of the arrowhead to coincide with what? The direction of the inequality. Let's try to solve the other question we have here. In the second question, we have x is less than or equal to 0. We have the number line. What's the next thing? We indicate 0. Then we indicate any other given number. Are we giving any other given number here? No. We're only giving 0. So you can just work with 0. Then we indicate a null on 0. But this time, we shade the null. Why are we shading the null? Because we have less than or equal to. So anytime we have less than or equal to, we shade. Or we have greater than or equal to, we shade. But if we have only greater than, then we don't shade. Okay, so here I have the shaded portion. Then I'm going to use what? The direction of the arrowhead as the inequality. So what's that direction? Towards here. So I have this as the representation. Then for the last one, I have the x. This is the number line. This is 0. Then I have what? 2. I have 2. This is x is greater than or equal to 2. So what values are greater than or equal to 2? What's the next thing? I'm going to erect a null at 2. Will it be shaded now? Yes, it will be shaded. It will be shaded. Why? Because we're having greater than or equal to. I told you. Once it is greater than or equal to, or less than or equal to, then we shade the null. But if it is only greater than or less than, then we don't shade the null. So what direction is it going to go? It will go in this direction. This is the direction. You can see the direction of the arrow here. So anytime we are given a particular inequality to solve, we can represent the inequality on a number line. So we can have a very complex equation like this, or simple equation like this, and we'll be told to represent the solution on number line just as we have here. But in this kind of inequality, we have two inequalities in one equation. So how do we solve it? We solve it as a simultaneous equation. We take the first two here, we solve, then we also take the other two here, we solve with the inequality. So we have two set of inequalities in here. We have 5 minus 2x is less than or equal to x minus 1, or x minus 1 is less than 4x minus 7. So I'll be solving the two of them simultaneously. So here, I'll collect like terms, collect like terms here. What do you have? You have minus 2x minus x is less than or equal to minus 1, okay, and minus 5, okay, that's for this, okay, or we have x minus 4x is less than, what do you have here? Minus 7 plus 1. So at the end of the day, what do we have? We have minus 3x is less than or equal to minus 6, okay, minus 3x less than or equal to minus 6, or here we have minus 3x is less than what? Minus 3x is less than minus 6. So at the end of the day, here I have a x. Of course, I'm dividing both sides by a negative number now. Divide both sides by a negative number, what happens? The sign will change. I have x is greater than or equal to minus 6 over minus 3. The sign changes. You can see that the sign changes here. What about here? The sign too will change because I'm dividing by a negative number. So I have x will be greater than minus 6 over minus 3. So at the end of the day, I have x will be greater than or equal to 2, or x is greater than what? 2. We can represent this on the number line. On the number line here, this is 0, this is 2, this I will shade. Why am I shading? Because it's greater than or equal to, and it will be facing where? It will be facing here. Or this 0, we still have 2, and this will I shade? I won't shade, and it will still be facing here. So you can see that equations on number line this way, equations that we have this way can always be solved and represented on number line. In the next video, we are going to see how we are going to convert from the number line to the graphical equation we are given. Thank you.